All right, this is the intersection of section 12.2, part 1, where we're talking about chords and arcs. And we've talked about central angles already. We're going to also talk about those as well here. Okay, so let's go ahead and get started. A chord is a segment whose endpoints are on the circle. But you'll notice the difference again about the chord compared to a diameter is that it doesn't go through the center. So your chord doesn't go through the center. Excuse me. Here it says the diagram shows the chord PQ and its related arc PQ. You see the red there is the chord, and the arc is related to that as well. Okay, we got some theorems and very important information here that we're going to talk about that you're going to want to make sure that you study because you're going to need to know these things. So, first theorem is theorem 12.4. It says within a circle or in congruent circles, congruent central angles have congruent arcs. So in other words here, what they're saying is that if angle AOB is equal to angle DOC, then their arcs are congruent as well. Because remember, if a central angle is 45 degrees, then that means its arc is 45 degrees. Or if a central angle is 67 degrees, then its arc is 67 degrees. The central angle and the arc are always going to be equal to each other. It's the same thing if we say that the arcs are congruent to each other, then the central angles are congruent to each other as well. Okay, theorem 12.5. It says within a circle or incongruent circles, congruent central angles have congruent chords. Now, I'm going to zoom in on this picture a little bit here because I'm going to show to you here's the central angle and here's the central angle, and the chords in this case are BA and CD. Well, if angle BOA is congruent to angle COD, if these two angles are the same, for example, let's say they're both 37 degrees. Okay? We'll say they're both 37 degrees. Then if that's the case, if they're both the same angle measured, then these two chords, BA and CD, are congruent to each other, which is essentially what it's saying in this statement. If the central angles are congruent, the chords are congruent, and then vice versa. If the chords are congruent, then the central angles are congruent. Okay, theorem 12.6 says within a circle or incongruent circles, congruent chords have congruent arcs. So, as you look at this picture, if chord BA is the same as chord CD, then their arcs are the same measure. Okay? So I know that if these guys are the same, and this guy, maybe we'll say this guy's 36 degrees, then this arc CD, is also 36 degrees. And then it goes vice versa. If their arcs are congruent, then their chords are congruent. Okay, so now we're going to use these different theorems and converses to work some of the problems. The last theorem we're going to look at here in part 1 is within a circle or incongruent circles, chords equidistant. This is an important word right here, equidistant. That means the same distance from the center, or centers are congruent. So what they're saying here is chords that are the same distance from the center are congruent to each other. So as I zoom in here to this picture, what they're saying here is that from O to F is the same as O to E. There's the same distance as each other. Then these two chords, C, D, and BA, are the same. They're the same distance. For example, if this is 15 and this is 15, and let's say CD was 27, then BA is also going to be 27. BA and CD are congruent to each other, which is what they're saying down here on the bottom. And vice versa. If the chords are the same, and they're both the same distance from the center, then the segments are the same as well. Okay, now let's take a look at some examples. All right, so we'll take a look here. We want to find the measure of arc AC. Arc AC is from A to C here, as I've highlighted. We want to find how much that arc is. You'll notice you see the arc AB is 130 degrees, and you'll see that these two chords right here are the same. Well, if the chords are the same distance, remember, if the chords are the same, then the arcs are the same. So since I don't know how much this arc is, I'm going to make that X. Well, I know arc BC is the exact same. And I know that there are 360 degrees in a circle. So I'm going to take X plus 130, and it's going to equal 360 degrees. Okay? I know that arc AC is congruent to arc BC because they're the same, they have the same distance chords. So when I figure this out, this is 2x to solve for x here. 2x is going to equal 230 when I solve that, and I divide by 2. X is equal to 115 degrees. In other words, the measure of arc AC is equal to 115 degrees. Okay? So in this case, I use the fact that this chord's distances are the same, so their arcs are the same. Okay, this one's a little bit more challenging. As I look at this one here, I see that I've got arc JK is 142 degrees, and arc JM is 38 degrees. And you'll notice that you see that these two distances right here, JK and ML, are the same. This happens to be a rectangle in this shape. So if that's the same, then that means that arc ML is 142 degrees. Okay, arc ML is 142 because those two distances are the same. And you'll notice also that these two side distances are the same. So if arc JM is 38 and the chord is the same, the chords are the same, that means that arc KL is 38 degrees. And the directions ask for what is the measure of arc KLM. So I want to know from here to here to M. Well, I'm going to simply take KLM is going to take 142 and add it to 38, which is going to give me 180 degrees for the measure of arc KLM. Okay, let's take a look here at the last two examples. What is the length of RS in circle O? Now, you'll notice as you look at this picture, we're going to go back to some of our theorems here. Remember, if two chords are the same distance from the center, then they're the same measure. And you'll notice that from O to this point and from O to Q in this case are the same distance. So in other words, we know that SR is equal to PR. And if you look here, you'll notice that the first half from P to Q is 12.5. Well, this has the same marking right here from Q to R, so I know that this is 12.5. Okay? Now, since I know those two are 12.5, I know PR is, if I add 12.5 and 12.5, I know that PR is 25. Which means if PR is 25, then SR has to be 25. Because again, the two chords are the same distance from the center of the circle. This goes back to one of the last theorems we looked at. Okay? As you look at this picture here, you'll notice that this distance of the chord is 36. And if you add these two together to give up that distance, that's also 36. Which means that these two chords are equal to each other. If the two chords are equal to each other, I know that they're the same distance from the center. Well, if this is 16, then X has to be 16 as well. Now, you'll see that knowing these theorems are important. So it's important that you study them. Okay, make sure that you study them so that you know them, because otherwise you're going to be pretty confused on quite a bit of this stuff. All right, this concludes part 1 of 12.2. Don't forget to complete your WSQ.